Hello students, welcome back to our class. Today I'll discuss the solutions of the problems that I had given you last week, and some of you have already done it very nicely. Many of the problems you have done very nicely, and some are still remaining, so let us have a look at how to solve those problems. Okay, so this was one of the problems. I have not written the question here. The question was basically you find out the number of squares in this particular diagram. Okay, yeah. So there were two questions about rectangles as well. So I'm just explaining it here. So forming a rectangle is actually equivalent to selecting any two vertical lines and selecting any two horizontal lines. Okay, so let us see. Suppose I select the second horizontal line here. Okay, and I select the fifth horizontal, vertical line here. Okay, and I select the second horizontal line here and the third horizontal line here. Okay, then immediately I get this rectangle. Okay, and the rectangle that is formed is this. Okay, we get this rectangle. So this is the rectangle that we get. So forming a rectangle is equivalent to selecting two vertical lines, any two vertical lines, and any two horizontal lines. Okay, each selection will give us a unique rectangle. Okay, so the case for squares is also similar. Okay, so for rectangle, how many rectangles can be formed using this diagram? There are how many vertical lines you see? Seven vertical lines, and there are four horizontal lines. Okay, so out of seven vertical lines, you can choose two in 7C2 ways, and out of four horizontal lines, you can choose two in 4C2 ways. So number of rectangles here will be 7C2 multiplied with 4C2. Okay, that's quite simple. Now squares, in order to form a square, we need to select two vertical lines, no doubt. We need to select two horizontal lines, that is also not a problem, but we have to keep in mind that the horizontal and vertical lines, they are equally apart. Okay, that is if we choose horizontal lines to be of 1 unit apart, okay, the vertical lines also have to be 1 unit apart, because for a square each side is equal. Okay, so this is what I have written. To form a square, we need to select two vertical lines and two horizontal lines such that they have the same space between them or the same distance between them. Okay, so in the given diagram, only squares of edge length 1, 2 and 3 units are possible. Okay, so let us have a look at this diagram. So in this diagram, we can form squares of side 1, we can form squares of side 2, we can form squares of side 3. Okay, but we cannot form square of side 4, because on the this horizontal, there are only four lines. Okay, in the horizontal there are only four lines, so only the square of maximum length 3 can be formed. Okay, so that is the thing. So this is what exactly I have written, that in the above diagram, the squares, only possible squares are of edge length 1, 2 and 3. Okay, so we have to find out number of pairs of vertical lines which are 1 unit apart. Okay, so which lines are 1 unit apart? This line, say 1, 2, 2. Okay, these two lines are 1 unit apart. Then 2, 2, 3, these are also 1 unit apart. Okay, then 2, 2, 3, this is 1 unit apart. Another thing is this, yeah, so 3 to 4, this is also 1 unit apart, right? 3 to 4, it's 1 unit apart. 4 to 5 also, it's 1 unit apart. 5 to 6, 1 unit apart. Okay, 6 to 7, 1 unit apart. Okay, so how many are there? There are 6 pairs exactly, right? 6 pairs, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Okay, these are the 6 pairs of lines which are vertical lines which are 1 unit apart. Okay, similarly there are 3 pairs of lines which are 1 unit apart in the horizontal direction. Okay, these are the 3 pairs of lines which are 1 unit apart, horizontal lines which are 1 unit apart. Okay, so we select any one of these 6 lines and sorry, any one of those 6 pairs, and on the horizontal side we select any one of those 3 pairs. Okay, so we will get a square, right? Suppose I select this the horizontal line, vertical lines corresponding to 4 and 5. Okay, so this is 1, and the horizontal line corresponds to, oh, sorry, I have chosen the vertical line corresponding to your 4 and 5. So I have chosen these lines, okay, this line and this line, okay, chosen this two, and I select the horizontal line corresponding to the second line and the third line. Okay, so this is the square that I get, right? So this way we can get one square. So number of pairs of vertical lines that are 1 unit apart is 6, and number of pairs of horizontal lines that are 1 unit apart is 3. So number of squares of edge 1 unit is 6 into 3, that is 18. Similarly, number of pairs of vertical lines 2 units apart. So the first line and third line, second line and fourth line. Okay, so that way there are 5 pairs. And number of horizontal lines which are 2 units apart is 2, 1, 3 and 2, 4. So number of squares of edge 2 units is 5 into 2, that is 10. And number of pairs of vertical lines that are 3 units apart is 4, 1, 4, 2, 5, 3, 6, 4, 7. Okay, just you can just make out, no problem. Number of pairs of horizontal lines which are 3 unit apart is 1 only. Okay, that is 1 and 4. So number of squares of edge 3 units is 4 into 1. Okay, so total number of squares will be 18 plus 10 plus 4, which is 32. Okay, now let us generalize this problem, a sort of generalization, because we are taking equal number of lines, equal number of vertical and horizontal lines. Okay, suppose there are n vertical lines and there are n horizontal lines. In that case, how many squares will be found? Okay, so it's similar. Number of squares of edge 1 unit will be how much? How many are there? 1, 2. Okay, then 2, 3, 3, 4, 5, 6, like that. 3, 4, 4, 5, 5, 6, 6, 5, yes, 6, 7, sorry, like that. So the last one will be n minus 1 to n. So there are exactly n minus 1 pairs of lines which are 1 unit apart. Okay, so number of similarly there are n minus 1 pairs of horizontal lines which are 1 unit apart. Okay, so number of squares of edge 1 unit is n minus 1 square. Similarly, number of squares of edge 2 units is n minus 2 square. Okay, number of squares of edge 3 units is n minus 3 square. Number of squares of edge r unit is n minus r whole square. Okay, like that. Number of squares of edge n minus 1 unit will be 1 square. Okay, so there is only one square of edge, the largest possible edge. There is n minus, there are n points or n vertical lines here. So the largest possible length of the square is n minus 1. Okay, so this is the thing. So the total number of squares will be 1 square plus 2 square plus 3 square up to n minus 1 square. That is n minus 1 into n into twice n minus 1 by 6. Okay, so this was the problem. And another important problem that I told you, it's exercise 28. How many numbers greater than 5400 have distinct digits and the digits 2 and 7 do not occur in them? Okay, so the numbers should be greater than 5400 and 2 and 7 should not be there. Okay, so since the digits are to be distinct, yeah, one more thing, the digits have to be distinct. So there are 3 conditions. The numbers are greater than 5400, the numbers have distinct digits. Okay, that means there are no repetition of digits, and the digits 2 and 7 do not appear. Okay, so since the digits are to be distinct, what is the maximum possible number of digits that has to be considered? It's 10 only, because any number having more than 10 digits will have repeated digits, obviously, because there are only 10 digits in the whole universe. Okay, 0, 1 to up to 9. So any number having say 11 digits has at least one digit repeated. Okay, because the first 10 digits will be from 0, 1 to up to 9. The 11th one has to be one of them. Okay, 0, 1 to. So this is one more application of pigeonhole principle which I will be doing. I don't want to do it online. Okay, let's see whether the lockdown is lifted or not. Okay, we want classroom lectures. Okay, that are much better. So okay, so as of now, let us see here. Any number having more than 10 digits necessarily has repeated digits. Okay, but 2 and 7 are not allowed here. Okay, that means what? We can just consider the number of digits to be at most 8. Okay, because 2 and 7 are not to be taken. So that means we have to work with only 8 digits. Okay, so number of 8-digit numbers, any number having 9 digits will have one digit repeated. Okay, because we are not allowed to take 2 and 7. Okay, so that means at most 8-digit numbers have to be considered. Okay, so the work is now simpler. Okay, so we first count the numbers greater than 6,000 with such properties. Okay, because for those numbers there won't be much problem. Okay, number of 4-digit numbers greater than 6,000. So let us do it digit wise. Number of 4-digit numbers greater than 6,000 with the given properties will be 3 into 7p3, because we are allowed to take only the digits 6, 8 and 9 in the first place. Okay, any number greater than 6,000 will be of this type, right? Any number greater than 6,000, so it will any 4-digit number, it will be of this type. There are 4 places. The first place can be filled with only 6, 8 and 9. Okay, and the second place can be anything other than 2 and 7. Okay, the third place can be anything other than 2 and 7. The fourth place can be anything other than 2 and 7. Okay, and since repetition is not allowed, we can just do it using permutation, 7p3. Okay, so the 7 digits have to be permuted among themselves, right? So how to do that? So that can be done in 7p3 ways. Okay, or just we can use the multiplication rule. Okay, it's all the same, because the formula NPR has itself been derived from the multiplication rule. Okay, so we can just apply multiplication rule as well. The first place can be filled up in 3 ways. The second place can be filled up in 7 ways, because the numbers cannot be repeated. Okay, well, we have 8 digits, except 2 and 7 we have 8 digits. Out of those 8 digits, we have already used 1 digit in the first place. That means we are left with only 7 digits. So it's 3 into 7. The third place can be filled with 6 digits. Okay, or the third place has 6 options. Okay, 6 ways it can be filled up, because the first 2 digits cannot be used. Okay, the third place has only 5 options. So it's 3 into 7 into 6 into 5. So these are the 4-digit numbers which are greater than 6,000 and have the given properties. It's 630. Number of 5-digit numbers having the same properties will be, so I have written it in another way. It's 8p5 minus 7p4, because there are 8 digits. 8 digits can be arranged in 5 places in 8p5 ways, but out of those arrangements there are some arrangements where 0 appears first. Okay, out of these 8p5 arrangements, there are some arrangements where 0 appears in the first place. We have to remove those arrangement. Okay, so that is why it's minus 7p4, because keeping 0 in the first place, there are 4 places which can be arranged in 7p4 ways. Okay, so it's 8p5 minus 7p4. So you can do it this way, or you can just do it directly by the multiplication rule. Okay, so I prefer the multiplication rule here. It's quite simple. Okay, the first place can be filled with 7 ways, yeah, in 7 ways, because 0 cannot be placed. Okay, the second place can be filled in 7 ways, because whatever I have placed in the first cannot be placed. So then the next place can be filled with in 6 ways, the next place in 5 ways, like that. So total number of 5-digit numbers having the above properties is 5880. Number of 6-digit numbers having the same properties is 7 into 7 into 7 into 6 into 5 into 4 into 3. Okay, these are the number of 6-digit numbers. Number of 7-digit numbers having the same properties will be this into 2. Number of 8-digit numbers will be same, just last it's 1. Okay, so in each of these I am just listing the possibilities of the places. First place can be filled in 7 ways, because 0 cannot be placed. Second place can be filled in 7 ways, because out of the 8 digits we have already used 1 digit in the first place, so we cannot use that again here. Okay, so 7 options. For the next one there are 6 options. For the next one there are 5 options. Okay, the number of options is decreasing, because there is no repetition of objects or no repetition of digits. Okay, so this is the number of 8-digit numbers which are having this given properties. Okay, so number of such numbers greater than 6,000 is this 94710, right? Okay, but number of such numbers greater than 5,400, okay, but less than 6,000 is what? How many such numbers are there which are greater than 5,400 but less than less than 6000. Okay, so that's what we have to consider. So the first place can be filled in one way, only because only 5 can be placed. Any number less than 6000 and greater than 5400 will begin with 5, right? The second place, there are how many options? Because 4 cannot be placed, 3 cannot be placed, 1 cannot be placed, 2 cannot be placed, 0 also cannot be placed. Okay, so what are the numbers we can place in the second place? We can place 4, that's not a problem. We can place 6, we cannot place 5. Okay, so 4 can be placed, 6 can be placed, 7 cannot be placed, 8 can be placed, 9 can be placed. So for the second place there are 4 options. For the third place there are 6 options, because I can place anything. Okay, except 7 and 2, and except the first 2. Okay, whatever I placed in the first 2 places, I cannot place them back again. So for the third place there are 6 options. For the fourth place there are 5 options. So total 120. There are 120 numbers which are greater than 5400 but less than 6000 and have those properties. Okay, thus the required number of such numbers is 94830. Okay, so this should be the answer, 94830. So some of you got it as 94670, something like that. Okay, so you please check. I think the problem that you did with suppose Shubhadeep did one problem. He had counted these numbers wrongly. Okay, there are some more numbers in this list because he has not taken the possibility of the second place being 4, 6, 8, 9. Okay, there are several possibilities here. Okay, so please try to do it again. Okay, next another problem that I'll discuss for today is find all solutions a, b, c, n in positive integers of the equation factorial 1 plus factorial a plus factorial b plus factorial c equal to 2 to the power n. Okay, so what are the positive integers a, b, c, and n which satisfy this? Okay, so let us have some look that if I take a as 1, b as 1, and c as 2, in that case factorial a plus factorial b plus factorial c comes out to be 4. Okay, and 4 can be written as 2 square. Okay, so one solution is already there, ready-made solution. Okay, so that means this equation may have some solutions. So to solve this equation, let us suppose that a less than or equal to b less than or equal to c. Okay, so it will make the things simpler. Yeah, so now we need to solve this problem, we will just need some idea of divisibility. Okay, and nothing else. So we have supposed that a less than b less than c. Okay, now see, the right hand side is only 2 to the power n. Okay, and the left hand side contains factorial numbers. Okay, now factorial n is divisible by all numbers from 1 to up to n, right? So this is the fact that is being used here. So if a is greater than or equal to 3, then what will happen? 3 will divide factorial a, right? 3 will also divide factorial b, 3 will also divide factorial c, because factorial a can be written as 1 into 2 into 3 into up to a, right? Factorial b can be written as 1 into 2 into 3 into a, then it will continue up to b, right? Factorial c can be written as 1 into 2 into 3 into a, then it will continue up to b, then it will continue up to c. Okay, dot c, right? That means what? Whenever a is greater than or equal to 3 will divide all these numbers. Okay, so 3 will also divide their sum. That means 3 divides 2 to the power n. But is it possible? It's not possible, because 2 to the power n contains only the powers of 2, means it's only divisible by 2. Okay, and powers of 2, by nothing else. So 3 doesn't divide this, so it's not possible. That means a cannot be greater than or equal to 3. So see, immediately our problem reduces. So a has to be less than 3, but a is a positive integer, so a can be either 1 or 2. So there are 2 cases which you have to study. Okay, so let us take it as case 1, a equal to 1. So if a equal to 1, then what we have, factorial b plus factorial c will be 2 to the power n minus 1, which is odd. Okay, so here again we can apply this particular method. If b is greater than or equal to 2, then what will happen? 2 will divide factorial b, 2 will also divide factorial c. Okay, that means 2 will divide factorial b plus factorial c, but that's not possible, because 2 divides 2 to the power n minus 1, but 2 is 2 to the power n minus 1 is odd. It's an odd number, so odd number is not divisible by 2. That means b cannot be greater than or equal to 2. So b has to be strictly less than 2. That means there is only one possibility for B, that is B equal to 1. So if A equal to 1, then B has to be 1. Okay, so next case, not the next case, the continuation. So A and B are both 1. That means if you put it in that equation, we get factorial C equal to 2 into 2 to the power n minus 1 minus 1. That means 2 into some odd number. Okay, that means what? Factorial C has only 2 as a factor. Okay, and 4 cannot be a factor of this, right? Because it is 2 into some odd number. So 2 appears in the factor only once. So factorial C should be less than or equal to 3, because if C is 4, then in that case 4 will divide factorial C, right? But here we see that 4 doesn't divide factorial C, only 2 divides. The highest power of 2 that divides factorial C is 2 to the power 1. Okay, right, highest power, I should have written it some other way. Highest 2 to the power n such that it divides factorial C is 2. Okay, that is the thing. So C should be less than or equal to 3. If C equal to 1, then what happens? 1 plus 1 plus 1 is 2 to the power n. So 3 equal to 2 to the power n. This is not possible. Okay, so C is not equal to 1, right? If C equal to 2, then in that case 1 plus 1 plus factorial 2 is 2 to the power n, which is possible. 2 to the power n is 4, that is 2 squared. So n equal to 2. So 1 1 2 2 is a solution. This is a solution, right? If C equal to 3, in that case what happens? It's 1 plus 1 plus factorial 3, that is 8. So n equal to 3. So 1 1 3 3 is also a solution. Okay, so that's not a problem. We come to the next case now. A equal to 2. Okay, then 2 plus factorial B plus factorial C is 2 to the power n. So factorial B plus factorial C is 2 to the power n minus 2. That means it is 2 into some odd number. Okay. That means only 2 divides factorial B plus factorial C. 2 square does not divide. Okay, because it is 2 into some odd number. So 2 divides this, but 2 square doesn't divide this. That means B has to be less than or equal to 3. Because if B is greater than or equal to 3, that is if B is greater than 3, that is B will be at least 4. So in that case 4 will divide this number, factorial B plus factorial C, but that is not allowed, right? So B has to be less than or equal to 3. Okay, but already it is given that B is greater than or equal to A. So B has to be 2 or 3. If B equal to 2, then what is the problem? The problem is this. 2 plus 2 plus factorial C is 2 to the power n. That means 4 plus factorial C is 2 to the power n. Okay, so factorial C is 4 into some odd number, right? So 4 divides factorial C, but 8 doesn't divide factorial C. Okay, and you will see this is not possible. Okay, but this is not possible. I have not continued here. This is not possible. Okay, because if 4 divides factorial C, then factorial C has to be 24, the minimum value. Okay, but whenever so that means C is 4, but in that case factorial C will be 1 into 2 into 3 into 4. So automatically 8 will divide factorial C. Okay, and if C is any other number, say anything greater than 4, factorial C will be always divisible by 8. This is not possible, right? If 4 divides factorial C, 8 also has to divide factorial C. Okay, that is the thing. So if B equal to 3, then what happens? 2 plus 6 plus factorial C equal to 2 to the power n. That means factorial C is 8 into some odd number. Okay, so 8 divides factorial C, but 16 doesn't divide factorial C. Okay, so C, it has to be less than or equal to 5. Okay, so that means but B is already less than or equal to C, so C is either 3 or 4 or 5. So if C equal to 3, then what happens? If C equal to 3, then we have factorial 2 plus factorial 3 plus factorial 3 equal to 2 to the power n. So that is 14 equal to 2 to the power n, but this is not possible because 14 is not a power of 2. Right? And if C equal to 4, then we have 2 plus factorial 3 plus factorial 4 is 2 to the power n, that is 32 equal to 2 to the power n, and that is possible because 32 can be written as 2 to the power 5, right? So n is 5. So 2, 3, 4, 5 is a solution. If C equal to 5, then what happens? It's factorial 2 plus factorial 3 plus factorial 5 equal to 2 to the power n. That means 2 plus 6 plus 120 equal to 2 to the power n. That means 2 to the power 7 is 2 to the power n. That means n is 7. That means 2, 3, 5, 7 is a solution. Okay, So these are the only possible solution: 1122, 1133, and sorry, I made a mistake. I think 1122, 1133. Yeah, 1133 is also a solution because it's factorial. Yeah, factorial 3. 1122, 1133. Then the other two solutions are 2345 and 2357. Okay, so they are the only possible solutions of the given equation, right? So this was this was the discussion on the problems. So tomorrow I'll come up with some more problems from previous Olympiad papers and all. Okay, thank you. And we'll also to take one test on a regular basis. So as of now, we will be taking online tests. So the answers have to be in 2-digit numbers. We will try to keep it in the PRMO pattern. So we will let you know. By the meantime, you please register yourself in the Google Classroom link that I had given. Okay, thank you.